everyone, it's Mrs. Scarpel, and today, or in this video, we're going to look at negative and zero exponents. And in the process, I'm going to show you why zero, the exponent zero, has the property it has, and why the negative exponents have the properties they have. So let's start with what we do know. We know that 2 to the first power is going to be 2. We know that. We know that 2 to the second power means 2 times 2, which is 4. And 2 to the third power means 2 times 2 times 2, which is 8. And 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. So as the powers of 2 increase, we just multiply by another 2. So let's think about this going backwards so that we can think about, or we can see what 2 to the 0 power is. If I'm going backwards, to go from 16 to 8, I would divide by 2. If I go from 8 to 4, I'm dividing by 2. If I go from 4 to 2, I'm dividing by 2. But another way we can think of that is that we are actually multiplying by 1/2. So as we go down this table, oops, got a little shaky there, we are going to be multiplying or taking the value times 1/2. Again, that's as we go down the table. So if I were to take 2 times 1/2, what would that be? 2 times 1/2. 2 times 1/2 is 1. So 2 to the 0 power is going to be 1. And to get my next value, I would take 1 times 1/2, which is 1/2. So if I go back into my expanded expression here, 2 to the negative 1 is the same as saying 1/2. We don't really have an expanded expression for 2 to the 0. 2 to the negative 2 then, well, if we keep multiplying by 1/2, that would be 1/2 times 1/2, which is 1/4. 2 to the negative 3 should be 1/2 times the 1/2, which is 2 to the negative 2, and then we multiply by another 1/2 because we're moving down our table. That's going to be 1/8. And because we're moving down our table, we take the previous row times another 1/2. So we have the 3 1/2 from the 2 to the negative 3 times another 1/2 for the 2 to the negative 4, and we have 1/16. And if we go yet another row, we would be multiplying by yet another 1/2, because as we go down this table, we're multiplying by 1/2, which is the same as dividing by 2. And we have 1/32. So if we think about what this expanded form could be in a simplified form, 1 over 2 is the same thing as saying 1 over 2 to the first. 1/2 times 1/2 would be the same as saying 1 over 2 squared. 1/2 times 1/2 times 1/2 is the same as saying 1 over 2 cubed. 1/2 times 1/2 times 1/2 is the same as saying 1 over 2 to the fourth. 1/2 times 1/2 times 1/2 times 1/2 times 1/2 is the same thing as saying 1 over 2 to the fifth. So if we take a look at what happened here, when we have a negative exponent, we can write it as the reciprocal, so we're flipping this to be 1 over, and the exponent becomes positive. So when you have a negative exponent, you can change it to the reciprocal and make the exponent positive to get your value. And when your exponent is 0, your value is going to be 1. Now we can also look at this from a general situation. So x to the first in expanded form is just x. X squared is x times x. So simplified, that is x squared. X cubed, expanded form is x cubed, or x times x times x. Simplified form is x cubed. X to the fourth is x times x times x times x is x to the fourth. Now if we want to go down the table like we did before, as we go down the table, if we are going to go to the row below, we would divide by x or multiply by 1 over x. So x to the 0, if I take x times 1 over x, that's going to be 1. So anything to the 0 power is going to be 1. Doesn't matter what number it is, how large or how small it is. Anything raised to the 0 power will always be 1. X to the 1, well, if I am going to be taking 1 and multiplying it by 1 over x, I still have 1 over x. So x to the negative 1 is 1 over x, or 1 over x to the first. Now if we follow that process of, well, to get the next row, I take that 1 over x times another 1 over x. That's going to give me 1 over x squared. So I could write x to the negative 2 as 1 over x squared. Taking my expanded form, multiplying it times another 1 over x, that becomes 1 over x cubed. So x to the negative 3 is the same as 1 over x cubed. X to the fourth, we take the row above, multiply it times another 1 over x, and we have 1 over x to the fourth. So anything to the negative fourth power can be written as 1 over x to the positive 4. And same thing with x to the negative 5th. So we would have 1 over x to the 5th, meaning x to the negative 5th is equal to 1 over x to the positive 5th. So again, when you have a negative exponent, you write the reciprocal and the exponent turns positive. Anything taken to a 0 power is going to equal 1 every time. So let's take a look at some simplifying that we're going to need to do. Here we have 2.5 to the 0 power. As we saw in both of our tables, anything to the 0 power is 1. You don't even really need to put much thought to it. Anything to the 0 power is going to be 1. Something like negative 3 to the negative 2. We have that negative exponent. So if we're just simplifying, this becomes 1 over negative 3 squared. So I'm going to point out this is a simplified answer. If the directions say to evaluate, then we actually find the value. Negative 3 squared. Now keep in mind you're doing negative 3 times negative 3. So a negative times a negative is positive. That becomes 1 over 9th. This is my answer when the directions say to evaluate. So simplify is just writing it to have positive exponents. Evaluate is telling me what the value is. Actually evaluating the value. Finding the value once the exponent is positive. Now here we have a situation where we have multiple pieces within our expressions. Everything has an exponent, and we need to simplify it. When you have a situation where you have variables and you have constants, generally you do evaluate the constant piece of the expression when simplifying. So let's take a look at A. We have a couple of pieces that we really need to consider. We have this 2 to the 0 that we need to look at. X squared has a positive exponent, so we don't need to do anything with that. And we have this y to the negative 2 that we need to consider. Now this y to the negative 2 is in the denominator. So in order to make it a positive, that is going to move to the numerator. And I'll explain why here. If I have an expression like 1 over y to the negative 2, that's the same thing as saying 1 divided by 1, let's see, how do I want to write this? 1 divided by 1 over, or no, that's it. I gotta write this correctly here. 1 divided by y to the negative 2. So 1 divided by y to the negative 2 is the same thing as 1 times, or no, not yet. I can't change it to a times yet. Sorry about that. 1 divided by, to write this with a positive exponent, we write the reciprocal with a positive exponent, but when we multiply by fractions, we have to multiply by the reciprocal. So this becomes 1 times y squared. So the y squared is no longer in any sort of denominator. That's why that can move to the top. 2 to the 0 is the same thing as saying 1. So this expression is going to become 1 x squared y squared. Or, as you will likely see in any sort of answer key, just x squared y squared. So if you have a negative exponent in your denominator, it can move to the top. That's the reciprocal of something being in the denominator, is that it goes to your numerator. If we take a look at example B, everything has a negative exponent. Because everything has a negative exponent, we can just write the reciprocal, we can just flip everything and change the exponents to positive. So this is going to equal x to the positive 4 over 5 squared over y to the first. Now, you wouldn't normally write something as y to the first, and when you have variables involved, you don't usually keep it as 5 squared. So to make this look prettier, is the word I like to say when we're writing mathematics, we have x to the 4th over 25y. So the key is, whenever you have something with a negative exponent, move it to the other part of the fraction. That's making it the reciprocal. Anything to the 0 power is 1. If you have an exponent of 1, of positive 1, you don't have to keep that exponent. It's just the variable, it's just the base. And if you have a mixed expression, meaning constants and variables, raise that constant value to its power to have it in its most simplified form.